Hello, friends. Welcome to Coding Garden with CJ. Welcome to Down the Rabbit Hole. So this is a Q&A stream. Thank you, Thite, for that resub. 13 months of support. I appreciate you, Thite. And Shorsey with 11 months. Thank you for that resub as well. But yeah, this is basically, it's a Q&A stream, but we're going to answer questions, but we will allow ourselves to be distracted by further questions that arise while answering the given question. So if you don't know anything about the thing that we're talking about, whenever we talk about that thing, I don't know what it's going to be, feel free to ask questions, anything and everything. There are no dumb questions. All questions are great. And we're just going to go down the rabbit hole. Welcome, everyone. And for those of you that are not familiar with the term down the rabbit hole, I will direct you to Wikipedia. But it's a metaphor. It comes from Alice in Wonderland, or Alice's Adventures in Wonderland. It's a metaphor for adventure into the unknown. So that's what we're doing today. We're adventuring into the unknown. Yeah, there are no stupid questions. No. I'll do my best to answer things, and also like provide resources if I can't answer something. But I will be pulling questions from Vox. So if you go to vox.coding.garden and Refactor, thank you for the 14 months. So much support. And you've got that founder badge. Come on, Refactor. I appreciate you. Okay. These are some commands you can run in the chat. The questions will pop up here, but I'll be honest. I will be honest. It's likely that we're only going to get to like one or two of these because we're going to embrace the tangents, right? We're going to embrace the question answering, and we're not going to try to answer all of them. The purpose is to maybe only answer one or two initial questions and then answer a bunch more questions about those questions. All right. If you're new here, welcome. First of all, you can play the drop game. !drop me in the chat. We'll drop your avatar. And there it is. That's me. And this is not a very good drop, but if your drop were to land in the garden, you'll get your name on your screen. Like, this one might land. Maybe. It's going to be a tiny one. Teeny tiny drop. Can't read their name. And Pablo, thanks for the bits. First question, what's JavaScript? We might actually start there. Thank you, Pablo. San Andreas Casino, great drop. Yeah, so the closer you are to the center, the bigger your name will be. There's lots of things you can do in my chat overlay. I'll let you all figure that out. It's your... I'm not going to tell you how, but you can figure it out. I'll give you, here's the thing. You don't need to run these commands, but if you want to know, that's how you set your country flag or set your team badge. This is how you set your pronouns in the chat. And you can also set your status, which should be appropriate for a professional environment of people watching Twitch. Okay, let's do a quick round of hellos. And then we'll get into it. We'll pick a question. We might actually start with what is JavaScript, because that's an interesting question, but maybe we'll choose something else. I think at least we'll do that at some point today. Okay. If you would like me to acknowledge you, you can say hi, hello, hey, morning, afternoon, evening, howdy, good day, coding, hi-o, vohio, or bogahay. Only these. Your message must match this regular expression. That's a question. What's a regular expression? But yeah, we're going to go back in time. We're going back to 13 minutes ago, where Coding Garden fan was the first person to say hello. Look at that. Thank you, Coding Garden fan, for being a Coding Garden fan. And what is up? Tactical Spartix and Elon Musk and Salty Ohm and JS Kenny and Mark and Netspud and Armon and DVF Des and Lakshman. How's it going, Lakshman? What's up, Mark Boots and Pablo and Chief Mustardo and Nafto and Dinafarb and Hive and what's up, Doc and The Art of Missy. Hello, what's up, Pucha and Advi and Richard Me and Jedi Master and Dynamic Voyage and Two Fox and Spy and Adamate and Julian. How's it going? What's up, Karzamte and the Ox D8 and Yash Kulani and Clicky Poo. Welcome, first time. Glad you could be here. What's up, Kuzi and Vujradane and Vaporvat and Abel working on a project. And you have to use Python. Python's cool. I like Python. I've done Python in my life. What's up, Brian? And Civason and Dropmania and CFM and Reekster and Syed and iHacks and Slake and Matrix Codes and the Omni King and Decline and Jim McDonald. I feel like it's been a while. Welcome back. Hello, DevNode. And Tamamek and Mo Saeed and Didart and Infinity and SQL Gordster and Chuno and Learning Developer is the regular expression case insensitive. It is, yes. This is the first question. You don't see it in here, but when the regular expression is executed behind the scenes, it is case insensitive. I believe. Yeah, because you can see that it detected capital H, hey, but it's lowercase h, hey there. Stafford, thanks for that Prime sub. Much appreciated. Welcome to the garden. We got lots of cool emotes here. We've got one, just one. We also have first try. This is we use this one a lot here because we do things a lot on the first try. Yeah, but welcome. Thanks for the sub. Use those emotes. Naveen, hello. In a Vue app, CSS on the page affecting the others. How to stop it? Use scoped styles. That's my answer. Search for scoped styles in Vue. Hello, Sheki, and Cookie Guy, and Leop, and Avos, and Cute Pony, and Simak, and GKIC, and Swan. Welcome, everyone. The gang's all here. That was a very quick round of hellos. I appreciate you all. Thanks for saying hello. Thanks for making that nice and seamless. Let's get into it. I'll read your question, Utamodia. I don't know if I'll answer it, but I'll read it. Learning Node.js and async versus sync, input-output. Currently, focused on set immediate and process.next tick. I'm wondering if there's a reliable way to tell what's synchronous versus asynchronous in Node. Also, how amazing would it be for CJ to dive into the event loop? Forgive me, I'm a noob. Yeah, the thing is, I don't know too much about the event loop. We would be learning together. Like, I know enough about the event loop. I know enough about the event loop to be really good at writing promises that work, promise chains that work on the first try. That's about as good as I am with the event loop. And really, yeah, it's probably as good as you need to be, I guess, depending on what you're doing. And hey, thanks for the 1,000 bits. Appreciate you. But yeah, so really anything that's going to be pushed into the queue. So anything that's doing something in the background and is pushed into the queue, that's what you can consider asynchronous, I would say. Meaning the code doesn't run top down. It's not synchronous. It potentially calls a function which needs to do some stuff in the background, which may not finish immediately. And then when that thing is finished, it gets popped off the queue, and then the potentially your callback gets called or the execution of a function resumes. So yeah. But even like set immediate and next tick, I would say technically you're passing in code that's going to be executed asynchronously because it's not executed immediately. It's pushed into the queue to be executed immediately. So those are technically asynchronous. I guess. I don't know. What do I know? What's up, Default? And Akashta and 0x Gamer and Samak and Miles and Dabda and iFills. How's it going, everybody? And Jalrar, good morning. Good morning. Welcome. Okay. Let's get into it. So Doc says process. Well, this is about the question from Eudaimonia. Process.nextTick is node specific, and set immediate isn't actually part of the spec. They're implementation details of one specific event loop implementation. Yeah. All right. Let's take a quick stretch. I need to thank anybody that subbed or gave bits that I didn't see, and then we're gonna pick a question. We have a lot of options. That's the hardest part, is just picking one. But we're just going to pick one and we're going to go. And Capio, welcome to the stream. Hello. All right. What has happened? It's a lot. Andrew 4 days ago with 13 months. I appreciate you. Cy Solix with that Prime sub yesterday when I wasn't streaming. Mark Boots with the 2 months 3 sub. Chief Mustardo with the 10. Devin with the 9. Oknot now with the 11. Almost a whole year. Yeah. Saludos amigos. CJ. Ha sido un año que aprendí mucho. hello, my friend CJ. I don't know what this means. I have 1 year something. Let's see what they were saying. Electrothermal, how's it going? It's been a year that I learned a lot. Nice. Nice. Thanks for being here. Do Prime subs support me just as much as regular subs? Maybe? I don't know. I can't answer that. But maybe. Fight, thanks for the 13 months. Shorsey Web, thanks for the 11. Refactor with the 14. Shot in the Dark with the resub. Always a good time. Thanks for being here. Pablo, thanks for the bits. Stavrid, thanks for the Prime. Again, Eudaimonia, thanks for the 1,000 bits. And 9 months. Shot in the Dark. Great. All right, let's look at Vox. Let's see what we got going. Okay, if you go to vox.coding.garden, you can actually vote on any of the questions that you see here. There have been quite a few, but like I said, there's a lot of people here. There's a lot of questions. We're only gonna pick 1 or 2 initially, and then we're gonna go there. All right, Lakshman has the question. What is a question? So a question is a way to. It's typically asked. A question is typically asked, though there are some floating questions that no one asks, but typically a question comes from one human, and they are attempting to understand something. So they ask a question to gain further understanding. So sometimes people ask a question out of spite, or ask a question to like put somebody on the spot, rather than really trying to gain further understanding. Humans are weird, but yeah, that's what a question is. I mean, we could start here. So I really want you all to vote. So if you go to vox.coding.garden, you can see the question numbers on the left-hand side here. And then if you do exclamation mark upvote followed by a number, you can pick which question we're going to start with. Well, thank you, Cute Pony. I did my best. Right now, there's only a couple of questions. I need you all to vote. Somebody vote on something. All right, we got to vote on that one. So in the chat, if you do exclamation mark upvote, let's say 2008, exclamation mark upvote space 2008, it would upvote this one here. If you want to talk about that one, vote now. Do I know Java? I've used Java. I mean, well, it was technically my first programming language in college, though I did write stuff before that. Yeah. All right, we got 4 votes on this 2Fox one. 2 votes on what is backend development. Java is horrible. Java's fine. Everything's fine. Actually, I mean, honestly, everything's horrible, which makes everything fine because, yeah. You can find something wrong with anything. Okay. You know, like, I'm gonna read this question. Actually, honestly, I haven't even read it. I see the block of text, but I haven't read it. But I like this one as a starting point because when we answer the question, "What is backend development?" we kind of have to answer the question, "What is front end development?" And then we have to differentiate between the two, and then we have to talk about all the thing in between things and stuff like that. So I like this question, but let's see what 2Fox is saying because it does have 4 votes, but they could be from fake users. I don't know if they're. How can I make a search input to automatically search on typing on mobile? NB Dealer. Thanks for that 10-month resub. Works perfectly on desktop, but on mobile, I have to press the search. I'm using View, and I have key up and key down set. Yeah, I know exactly what you're talking about because I have this Pokemon website that I've been working on, and I have an instant search box on the homepage. So here, like if you type Pikachu, you see I didn't press enter. There's a debounce on the input, and then when the user's done typing, it hits the API. Now, wait, what was your question though? On mobile, I have to press the search button. You know what? I think this actually works on mobile. You can try this. If you go to jpokemon.versal.app on mobile, I think it instantly searches. let's see. Maybe it doesn't. Maybe that's what I was running into. Oh, you know what? I think it works on the homepage. So it works on the homepage, but that's because, yeah, that's because I actually have a watcher on the input. So it's not like a key up or a key down event. It's a watcher on the input. And when the input changes, it then calls the API. Now, where it doesn't work is if you go to one of the specific expansions. So if I go in here and then we look at like Shiny Star V, on mobile, if I type in this search box, well, obviously hello is not a thing. Let's search for Charizard. If I type in this search box, it instantly filters on desktop, but on mobile it doesn't. And that's because I'm using vModel. Yeah, so here I'm using vModel, and on mobile that value doesn't change until the input is cleared. Oh, it does. It does too, Fox. Yeah, so on the homepage, just type in Zard. Now, your keyboard is probably going to be in the way. But if you scroll without the keyboard, it's there. The results are popping up. It's just that the keyboard is in the way. And I mean, you can, let's see. Maybe it isn't. I don't know. Actually I don't have the code for this up, but here's my tip for you. Instead of using vModel, instead of using key down or key up, have an actual watcher. Well, I guess if you could use key up, or the thing is I have vModel with a watcher. I don't know. What you need to look into is the fact that on mobile the vModel isn't updating unless the input is unfocused. So it basically doesn't update until on focus leaves. Yeah. I don't know. I don't have a good answer for you, but I've decided we're going to start here. This is our first question. What is backend development? And we'll type some things out. I also have a Lucidchart document open, and we'll try to make some diagrams for it. But here's our first question that comes to us from Lakshman, which is, what is backend development? Now, can I get a show of hands? Who here is new to this kind of thing in general? Who here like doesn't know how to code or is interested in coding? Just smile in the chat, because I'm tempted to even explain the word development, or explain the word backend. But yeah, so the question is, what is backend development? Nice, Rowaneb. Well, don't cry. Well, I guess you're crying because you do know it. Junior developer, still don't know how to code. Cool. Let's try to do a diagram of sorts. Okay, so this is the rabbit hole. We're starting here. And then we're going to go to what is backend development. Now, I guess the thing to talk about is, I guess we could define the word development. Let's do that first. Like, what is development? And there are a lot of terms we use in the programming world to describe what we do. So development typically means like writing software or writing programs, which is basically the same thing. Like these two words are often used interchangeably. You could get into like why these are actually different, but those are also used interchangeably. Writing code. Again, we can get into the semantics of the word code, or like writing apps. To me, and also from like for anybody, yeah, like all four of these sentences to me mean the same thing. Obviously, you can nitpick and you can talk about how these words are like slightly different, but that's really what development is in general. Is you are writing some sort of computer code for end users or for yourself or something like that. Does it have similarities to, let's say, housing development? Probably. So like a housing development is like a subdivision. So I don't know if this happens in other countries, but like in the US, There'll be like a specific part of a city or a town where they start building a lot of houses, potentially all owned by the same developer, housing developer. I think you could probably use them interchangeably, just because like in the programming world we also use the terms like architect, which is not very similar, but in relation to what they're doing with the job, it's similar to what an architect would do in the physical world, in that they're designing the thing, not necessarily implementing it or building it, but they're designing the whole. Development equals copy pasting, potentially. Development, a trial and error process where you gradually approximate code that does useful work. Yeah. Yeah. And definitely, like, this is accurate. So software architecture problems, some of them are inspired by like physical architecture problems. Okay, but regardless, so first of all, in this term backend development, it involves writing some sort of software, writing code, writing programs. That's what you're doing with backend development. Now, this other piece, the backend, the simplest terms is the part you don't see. Like the end user, the part of an app the end user does not see. For an end user, the back end is elusive. Typically, when we talk about the cloud, we typically mean the back end, though. I mean, some of the front end code you're writing is technically hosted in the cloud, but the back end itself is typically what we mean when we're talking about APIs, if you've ever heard this term, or more specifically, web APIs. Yeah, I mean, even front end code can be a mess, but yeah, this is a common theme that since it's not seen, that it is a mess. But I mean, most code is messy, honestly. Yeah, and Lakshman is asking, what is cloud? I mean, I feel like this is like a pretty big buzzword. I don't know when it started being a buzzword, but like you talk about, like, I have a Gmail account and all my emails are in the cloud, or I have an Amazon Alexa and it adds things to my shopping list in the cloud. The cloud follows you around, but not really. It's and Tim, thanks for that Prime sub. Yeah, I mean, the funny term people typically say is other people's computers, or someone else's computer, right? But I guess let's also define this, because typically, like, backend is mostly server-side development, and we can talk about like what is a server, but like, so this in general terms, we can split up typically the web applications we build, or really like mobile apps and web apps. I mean, often desktop apps can be split up in this way as well, but we typically split them into two parts. Now, they don't necessarily have to be, but we typically do. So one of the parts we split it into is the backend. This is the part that users can't see, and then you also have the front end, and this is like the user interface, what users see and interact with. So, for example, if we just take Google, or we'll take DuckDuckGo. If we go to duckduckgo.com, this is my preferred search engine. This is a front end. This is a front end. No, we're live, Deseros. We're live right now. Isn't a cloud just a server? Yeah. I mean, you can think of it like that, but we are going to, we're going to expand on that a little bit more. And Eddie, thanks for that Prime resub. You're very welcome for the lessons. Okay, so when you go to a website, it doesn't have to be DuckDuckGo. I prefer DuckDuckGo, but when you go to any website, the thing that you're seeing in your web browser, or the thing you're seeing in your web browser on your phone, if you use Chrome on your phone, or Firefox or Safari, the thing you're seeing is the front end. It's what you interact with. It has buttons. It has things you can type into. So this is the front end. It takes many shapes and forms, right? There's a lot of different kinds of websites, and they have a lot of different front ends, but the thing that you're seeing and interacting with, and the thing that's running in your web browser, that is the front end. And so we differentiate that from backend because there's apps are complex. There's some processes involved, right? So on DuckDuckGo, when I actually we'll see something happen here. The moment I start typing, you can see that it's dynamically suggesting things for me to search for. Now, there is front-end work involved in displaying these dynamic things, but you have to wonder or think the question, where are these suggestions coming from? How does it know? What else can we search for? Twitch Prime? Twitch. any primers in the chat? Twitch Prime? What else can we search for? Backend developer. Backend meaning. So here's the thing to think about, right? It's providing suggestions. iFills! Thank you. Thank you for that Prime sub. So you're wondering the question, where does this data come from? This data is coming from the backend. And that's why we talk about these two things in separate parts, because you can only code so much for the front end, right? Now, like technically, these suggestions didn't have to come from the backend. It's possible that whenever we go to a website, whatever loads for us is anything and everything we would ever need. But you can see how no matter what I type in, I am getting suggestions of what to search. So these things have to be coming from somewhere. It's coming from the backend. And there's more involved there, because then you have to think, well, how do they know about all this? Well, then we have databases, and that's how we can keep track of persistent data in the cloud. But yeah, like if you want to demystify this, that's a good point, 2 cents. Like if you want to see what's happening here, just do this. Right-click the page, click on Inspect, and then click on Network. And so this will actually show you all of the network requests that are happening on the page. That's potentially something else we need to define, like what is a network? What is a request? But check this out. When I type the word banana, we see these requests coming through. These are requests happening on the front end. So somebody wrote code that is running in your web browser. Like when I'm typing the word banana bread, there's code running in the web browser that's taking what I've entered into this input here and sending it to a backend server. And then that backend server is responding with this list of results. So for example, if we look at this last one, we can click on response. We can see that like this is what came back from the backend: banana bread recipe, banana bread recipe easy, banana bread demo. So all of this data we're seeing here came from the backend. And that was an API request. But another thing I probably need to talk about is data formats, because what we're seeing here is actually known as JSON data, JavaScript object notation. And if we're getting this data from somewhere, that data has to be in a consumable format, right? Like we have to agree on a standard so that when the backend sends the front end data, the code that is used to decode that data consistently works. And that's where something like JSON comes into play. And somebody mentioned XML. Really, let's just talk about data formats or data encoding. So JSON is by far the most popular nowadays. And this stands for JavaScript object notation. And XML is... Wait, is it something markup language? What is the X stand? Extensible? Extensible. Yeah, I don't like that because the X is not the first letter. Cool, that makes sense though. Yeah, but there's also YAML. Cool. Yeah, you all can help me out. Just send me data formats. What else? What are some other data formats people are using? There's BSON, which is binary JSON. Yeah, protobuf. Yeah, technically you could have an API that returns CSV data, and then you could have front-end code that parses CSVs. That's a thing. Yeah, I guess, well, base64 is an encoding. It's not necessarily a data format. Because you can encode JSON data in base64. Yeah, we can group these together, like comma separated values, tab separated. I mean, we should expand all of our acronyms. Comma separated values, and then there's TSV, which is tab separated values. But you could think of this like a spreadsheet. I mean, it is a spreadsheet, but it's like a pure text format that isn't not. I guess it's not proprietary, because if you look at an Excel file, they use an open format for that, but it's not CSV. There's a lot more stuff encoded in there. Hakan? I've never heard of Hakan. Plain text, yeah, that's absolutely a data format. What was the most popular before JSON? It was XML. So yeah, so when I started my career, pretty much everything was SOAP APIs with XML. I guess we could dive deeper in here into like I guess types of APIs, because most of what we deal with these days are a type of JSON API. But then you can't really even say JSON API, because JSON API itself is a specification. I'll just say a backend server that returns mostly JSON data. That's the kind of APIs we deal with these days. There's also SOAP, which is a very specific standard for response, like for how you define your response handlers and the data format that comes back. And this is typically backend server that mostly responds with XML and adheres to the SOAP. Is it a specification? IML. I haven't used IML. What is IML? SOAP. Yeah, gRPC is General Remote Procedure Call. Yeah. Simple Open Access Protocol? What is that? Okay, but let me just look up SOAP really quick. We're literally going to search Wikipedia for SOAP. No, we want the disambiguation. And we in science and technology. Wait, Simple Object Access Protocol is what SOAP stands for. I see. It's a messaging protocol specification for exchange structured information in the implementation of web services and computer networks. Is it service-oriented access protocol? Are there two different kinds? Oh no, not sugar SOAP. So okay, but yeah, obviously we're going down the rabbit hole, but we're going down, we're going back up. The other type of API is typically a RESTful API. The thing is, you could have a RESTful API that returns XML data. That is isn't that possible? It's possible, right? The REST specification doesn't specify that it needs to be JSON, does it? Representational state transfer. Yeah. So REST APIs technically can respond with XML or JSON. Like this, the representational state transfer style doesn't specifically say that it has to respond with JSON. Yeah. Why would SOAP not be a clean definition? Okay. But yeah, REST is a software architectural style. There's so much to unpack here. There's so much to unpack. Okay. So yeah, there's a lot of different kinds of APIs. You have your REST APIs, you have your SOAP APIs. I'll just say that SOAP is like not used as much anymore. You also have GraphQL, which is surprisingly, this is not a database technology. This is not, Yeah. I mean, a lot of people think about GraphQL as a database. GraphQL is a specification for building backend APIs. You're telling me. Yeah, I mean, GraphQL is JSON based, like typically uses JSON, but it is a query language, and it's a specification for designing or defining your schema types and how your API will respond. GraphQL repeating all the mistakes of OData, but in 2021. I remember OData when I was dealing with SOAP. Open Data Protocol. Yeah, this is a thing. This is definitely a thing. But yeah, this is OData encoded with JSON, and then you can also have OData encoded with XML. Maybe SOAP is resting. Yeah, it's just that, like, JSON is the superior data format compared to XML. I mean, in a lot of ways, like JSON is less verbose. What's interesting about XML, though, and probably like why it was so prevalent for so long, is that it's in a similar format as HTML, and browsers can already parse HTML. So before the JSON was actually in the JavaScript programming language itself, like it was really easy to get XML data, put it into a DOM, and query it just like you would the HTML. But these days, JSON is native to JavaScript. Yeah. What is CData? CData is a way of encoding data within XML. We're not going to go too far down that rabbit hole, but that is a thing. Typically, you see CData associated with XML. CData. Yeah. Character data, and the purposes in the markup languages HTML and XML. Yeah. Okay. Let's try and figure out where we are in this rabbit hole right now. So the initial question was, what is backend development? Okay, first of all, we started by defining what development was. These are all sentences that pretty much mean the same thing to me: writing software, writing programs, writing code, or writing apps. Right? You're basically building software of some kind. Okay, so that's development. And then when we talk about backend development, we are differentiating that from front-end development. And so to know what back-end development is, you need to know a little bit about front-end to know like why we differentiate them. And so we basically talked about like the front-end is what the user sees and interacts with. So the example we used was like DuckDuckGo. This website we're looking at is a front-end. But then when we're using the web page, as we start typing, we see dynamic data here. And that data has to be coming from somewhere. That data is coming from a backend. Right, and so this is really the part of the app that users don't see. It's all the complex stuff happening behind the scenes, and the end users don't need to see it. Like end users shouldn't have to care about what the back end is or what it is doing. All they care about is the front end experience. But what we showed is if we look at the network tab, we can actually see that this web page is making requests to a backend server to get data, so that it can make this UI give us suggestions. And then that led us to this here, because this is JSON data. It's in a JSON format. And actually, if I open this in a new tab, we can actually just, it's asking me to download it. I don't want to download this JSON file, but you can see that technically I could go here, and then instead of seeing the request here, I would get the actual data itself. So, so far, the back end is the stuff users don't see. And one of the things that backends deal with is data formats, which we got here. Because if the backend and the front end are going to be communicating, then there needs to be some sort of standard format that they can communicate in. And that's why we talked about, or we just slightly mentioned JSON. Each one of these bullet points is a potential rabbit hole we could go into. But the thing that I want to expand on now is what is a request? So like how is this front end and back end communicating? We talked about, let's take a quick stretch. Back end is what the user feels. Jahituts? What is this image? Anyone tell me what that image is? It's rabbit holes inside rabbit holes. Okay, so we've differentiated between front end and back end. We see that a front end potentially needs some sort of backend to make it a little bit more interactive. I will say it's possible to have websites that are only front end. It's possible to have websites that do not have any sort of like backend interaction. It's safe, says Ed. All right, let's look at it. Nice. No. Oh, okay. Yeah, this is a funny image. This is kind of like a classic programmer joke where like the front end, because it's what the users see, it's nice and cute, and there's rainbows and butterflies, but then the back end is a complete and utter mess. In my professional experience, but see, this is comparing two different things, right? It's comparing the front end that the users see. But there's another aspect to the front end, which is the actual code written to build that front end. And it's possible that that code is also a giant mess, just like the backend code is a giant mess. But this is, I guess, more referring to like the interaction of the backend and stuff like that. Yeah. Stephen E is saying the backend has users too. Yeah, I mean, that's a potential another rabbit hole we could get into, though, is the fact that these APIs that are potentially being exposed by a backend, like these APIs are ways of getting data from that backend. This could potentially be a product that a company offers. Like a company might actually offer up their API for other developers to use. And so in that way, developers are users of that API. But also, like on this website, if they had different front-end and back-end developers, the front-end developer is a user of this API that the back-end developer created because they had to write the code to interact with it. So that's an interesting aspect as well. Yeah. Would that be like a static app, an app without a backend? Yes. I mean, and there's a little bit of nuance there because technically, if you want to take this static app and put it on the internet, it needs to be put onto a backend server. And that's a whole nother rabbit hole we could get into. But if you can find yourself a static web host, I mean, Netlify drop comes to mind as like one of the easiest things. Netlify drop. Because for non-programmers, you can literally take your static, I mean, I guess you'd have to be a programmer to build the website, or like a basic front-end programmer, but you can take your files, you drop them here, and now they're on the internet. But this is a static, when you do it this way, it is a static file host. It's literally just running your front-end files. Revive Newt! You're here! 10 months, thank you so much. Oh, I appreciate you. Thanks for that tier 3 resub. But yeah, people drop their static files here. It's on the interweb, but those static files, depending on the site you build, technically don't need a backend. Yeah, like it could just be a static website. Now, in this case, Netlify like is your backend host, but you don't have any sort of server-side backend dynamic logic. It's just a front-end website. That is the thing. Yeah, and so a static site it's not necessarily an app without a backend, because you could have a static website that communicates with backend APIs. Yeah. Okay, we're gonna keep moving, but yeah, hopefully that helped a little bit. Backend code should be good for security, right? Yeah, I mean that's an aspect that we haven't mentioned here, but we definitely should. And we'll talk about that more. But like, for someone. And Freak Zombie, thank you very much for that Prime sub. Or you upgraded. You upgraded from Prime. I appreciate you. And Hawknot now, thanks for the bits. I like the way you explain things. Thanks. I'm trying my best. But we'll get into this because we have not talked about... so we talked about data formats, but we also need to talk about databases. And so this is persistent data storage. And it's what allows... the world to work the way it does, right? When you go to twitch.tv, you see a list of all of the channels that you have followed. How does it know? How does it know that you're following Coding Garden? That's stored in a database. And no matter where you visit the website, and Gene, thanks for that Prime sub. No matter, whoa, Elon, you upgraded too? Ah! Thank you. But yeah, no matter where you log into Twitch, whether you log in on your phone or your laptop or your tablet, it knows who you're following. It knows, but that's stored in a database somewhere. And then when you go to the website, Their front end makes a request to the back end. The back end responds with some sort of data format, probably JSON. Well, actually, it does respond with JSON. And then that's how you see your list of followers. We have more to talk about, though. I do want to talk about requests because we haven't talked about this. Like, how are the front end and back end communicating? Yeah. But yeah, so like you could have a static website that shows recipes where you didn't build the backend, but you're interacting with some sort of recipe API that somebody has published and you've written code to interact with that. But you've still only technically written a static website, though it's making requests. What's the best way to learn a language? It's hard for me to answer this question because I've been programming for so long. And for me, I kind of just dive right into things because in the world of programming, like there are a lot of commonalities. There's a lot of things that are very similar regardless of where you're programming. So if I had to write a game with C++, I would just dive right in. You'd have to pick like probably a game engine. And then from there, maybe I'd try to find some samples and then modify those samples to do what I want to do. And then maybe eventually write my own thing from scratch. But as someone, I mean, and yeah, I guess I don't know you. Maybe you do. Maybe you are a programmer. Maybe you have done other things. But that's basically what I would do. Typically, I like to find or try to find some sort of example that's similar to what I might want to build. And then just look at the code directly, try to understand it, and then start to modify it to do what I want it to do. Now, that's not the only way to learn. You could technically go straight to the documentation, or the people have probably published tutorials and you could follow those. But that's how I learn best, is just like immersing myself in something. Yeah. Why difference between front end and back end? Yeah. So I think we'll get to this right now if we talk about security. Like you might be asking the question, why are we splitting these things up? And Plankal, thanks for that Prime resub. Yeah, so we talked like there is a back end, there is a front end, but why? Why can't it all just be on the front end? Let's talk about that next. Yeah. Good morning. Yeah, thank you, Revive Newt. Any option in React like an HTTP interceptor in Angular? So if you're using Axios, Axios has interceptors. And what's up, Greg? Thanks for being here. I do have my Newt screen. I don't know where it is, though. How's the data fetched from the database? Well, yeah, we're not there yet. That's deeper into the rabbit hole. Because we still have to describe what a database is. I mean, obviously, you might know what one is, but I'm trying to describe this in a way that, like, most people could understand. Yeah. W3 schools. What's happening? What are people talking about? Yeah. Cool. A really big Excel file is what a database is. Okay, so you might be asking the question, why do we split these two things up? One of the main things is security. So we're about to explain what databases are, but I did say they are persistent data storage. It's like it's storing data somewhere that can be accessed usually from anywhere via some sort of web API that returns that data from the database in some sort of data format. But all of that is locked behind this backend, and then the only way that the front end can get to that data is via some sort of request. It has to like request that data from the backend. And we can think about this in terms of security, right? Like when you go to twitch.tv, you don't see, like you see your information. You see who you're following. You see your private DMs. You can go into your settings and you can see all of those settings, and that's specific to you. But when somebody else logs in, they see their own specific information, right? How do we make sure that users are only seeing what they're allowed to see? That comes into play with security, and the backend has that. Not now. Thanks for the bits. Programs are like augers and onions. They have they have layers. Ogres and onions. They have layers. Yeah. I like this. This is better than a well-written book. I'll have all my thumbs up. Well, thanks, Elswee. Okay. But that's the thing to think about here, right? Like when you go to websites where you're logged in, you have a different experience than someone else who is logged in. You see your specific things. And if we didn't have this backend restricting that, then it would be a free-for-all. Everybody could see everybody else's data. Everybody could modify everybody else's data. So that's why we do have this separation. And when you're writing a backend, you absolutely have to take security into account. So you're storing data in databases. You're building APIs that return data in data formats. But in front of all of that, Sledge Dog, thank you for that reset. But in front of all of that are middlewares. We can talk about middlewares. This is a very general term, but basically this is code that runs before some other code runs. And that code can check things. It can say, okay, who are you? Like what do you have access to? And all right, when I'm responding from this specific web API, I'm only going to return this specific data because that's what you have access to. And David Altretter, thank you for that resub. So that's the main reason why we separate these things from the front end and the back end is we want users to have different experiences when they're visiting our website, potentially, if you have login and persistent stuff. And then we don't want users to be able to affect other users' data. So that's the main reason we split it apart. And that's why we absolutely have to think about security when we are building a backend. And Mark, thank you for the bits. Let's take a step back out though, because I talked about, okay, we split it up into two parts. We have backend and front end. How do they communicate? They communicate over the network. What is a network? It is a series of connected computers. And that's all of this is on the internet. And Helon, thanks for the bits. I might start doing coding live streams, but in Spanish. Oh, that'd be great. You absolutely should. I know there are a few Spanish-speaking streamers, but there aren't enough, so do it. And Koozie, thanks for the bits. Hello, welcome. Okay, so if you're watching Twitch right now, you probably have a general idea of what the internet is because this is happening over the internet right now. That's what's happening. But the internet itself is a network, which is a series of connected computers. I kind of do want to just show a visual example. Like it actually probably won't be that useful, but I'm going to do it anyways because I know where some stuff is that I can use. Also, watch this. I bet you didn't expect this. I have a standing desk now, but I'll be right back. Okay, so we're talking about a series of connected computers. How are these computers connected? Literally by wires. So I have here I think it's like a Cat6 cable. You've probably seen these before. They look kind of like a phone cable, if you know what a physical phone is, but it's a little bit bigger than a phone cable. This is an example of an internet wire. There's lots of other kinds. There's fiber optic cables, there's coaxial cables. There's a lot of different ways to connect two computers together. But basically, one end of this wire goes into a computer. This is a little mini computer. Obviously, it's mini, it's small. But you could imagine, and actually, I'll tell you that, the only difference between this computer and computers running Twitch or computers running Google is that those computers have more processing power. So this is a tiny little computer, but it still has an Ethernet port. It has USB ports and stuff like that. So this computer is connected to a wire. The other end of that wire is connected to some sort of router or switch, some way for it basically allows for that computer to communicate with other computers. So we take this end of the wire and we put it into a router. Okay, so here's where we're at. This computer is communicating, like it's sending data over this wire into this thing. This thing, it's like a, what do we call this? The orchestrator. This thing makes it happen. So let's say we have some other computer. That other computer also has a wire, and then that wire is plugged into this thing here. I can hold this all. So basically, these two computers are totally separate. Two totally separate computers plugged into two totally separate wires, but they're plugged into this thing, right? And this thing helps those two things communicate. So this assigns both of them a specific address. So you can think of it like it assigns both of them a specific phone number, so that when one thing is trying to send data to the other, it can dial to that specific phone number. Great. Now, obviously, I'm showing you. This is all I have in my hands. This is not the internet. My cursor is where did my cursor go? This is not the internet. This is an example of a local network, because these two things are plugged together. Now, the internet is basically this, but on just a much bigger scale, and that's really all it is. And actually, the way that I could get this to work is wirelessly. So this router can actually wirelessly connect to some other router. That router could be connected to a modem. That modem is connected to an internet service provider, and that internet service provider is connected to the backbone of the internet. But basically, at the end of it all, it's all just wires. It's just wires. So computers are connected to each other via this, and then there's basically just tons and tons of these. Not all of them are wireless. You have switches, you have controllers. Yeah. There is no internet. Yeah. So, but that's one way to think about that. Is like computers are connected together. And we talked a little bit earlier about like what is a server. When did we talk about that? Yeah, we talked about the cloud being someone else's computer. That's literally what it is. I mean, this is a computer. This could be a server. I have a laptop right here. This could be a server. Whatever device that you're watching this on, that actually could be a server as well. Even a phone. A phone could be a server. It literally is just a computer that's running a program that can respond over the network. So you have a program listening here, and this thing is connected to the router. And then that other computer wants to make a request here, but because this computer has a program running that's listening, it can make a request and then respond. So all of that to say, yeah, so you have these series of connected computers, and these computers need to communicate with each other, so they make requests to each other. You basically have requests and responses. But Anna says, you're saying the cloud isn't real. Yeah, the cloud is a metaphor, because the cloud is literally just all of these connected computers. I mean, the term cloud is typically used for like software as a service providers that are doing things for you in the cloud, like Gmail or like Amazon, that kind of thing. But regardless, you have a network, which is a series of connected computers. These computers need to communicate. And they typically do that with requests and responses. Now, there's a lot of different ways for these computers to communicate. There's a lot of different protocols. Let's list this out here, because we're not even at requests and responses yet. So help me out. What are some protocols that that computers can communicate with? We know of one. TCP, HTTP, FTP, UDP. What else? ICMP. NetBIOS, is that a thing? I'll put it down. I don't really know. There's also, yeah, HTTPS. MTP? What is MTP? I2C? 2CB? RTMP? SSH? That is probably enough. And many, MTV, ESPN, and many more. But basically, people have opinions. Programmers are people too, and they have opinions about how things should work. And some of them think that some things are better than others, and so they invent new protocols. Now, as that said, some of these protocols have specific uses, like FTP is File Transfer Protocol. Protocol. And so this is a protocol for how to transfer files over two connected computers. And I guess we need to define protocol. This is just like a general definition, because all of these protocols are that. And Aknat Now, thanks for the gift. Yeah, a protocol in simple words. This is an agreed upon standard of communication. So I feel like we've talked about this on the stream before, but basically, before two things can communicate, before two things can exchange information, they need to agree on how they're going to do that. And that's what all of these are. All of these are basically agreements on how they're going to work. Can anyone think of a better definition of a protocol? Did that help? Anybody that didn't know what a protocol was? Yeah, you could call it a grammar. Yeah, because like in the English language, grammar is the agreed upon rules for how the language itself works. I mean, people break those rules all the time. I'll say in computer programming, you can't really break the rules. If you break the rules, it's not going to work anymore. Yeah. All those things run on top of TCP or UDP and IP. Yeah, so TCP, UDP, IP, these are high-level protocols. And then you have these are low-level protocols, and then you have higher-level protocols that run on top of those protocols. Let's split them up. So you have low-level, and then you have a higher level, I guess we'll call it. Yeah, you could say we have layers. And then that gets into the OSI model of how the, like, I don't know if we need to talk about that. I'll mention it because this is something that you could look into more. Let's see if we search Wikipedia for OSI, if they'll know. Technology. Wait, is it OSI? Yeah, here it is. Open Systems Interconnection. So this is actually where it comes into play. So when people are talking about OSI, they're talking about how computers communicate with each other. And typically it splits it up into different layers. You have the physical layer. So that's what we showed here. Like the physical layer of the network is literally, it's the wires, it's the routers, it's the switches, it's the computers. That's the physical internet and networks connected together. I honestly don't know what each of these things are, but I could infer. You have the data link layer. Maybe that's separate. The wires themselves are the data link layer, like how you connect those computers together. You then have the network, which is how they communicate over that wire. And then you have the transport layer, which is how data is transferred over that wire. And that's where these protocols come into play, TCP, UDP, and IP. Those are all happening, I believe, in the transport layer. 2 is switches. Yeah, I probably could read this and learn about it. The USB layer, walking data between computers. Cool, but this is definitely a thing. People know a lot about it. I know enough about it. Yeah, and at the end of the day, like when I'm writing programs, I typically don't have to think about any of this. That's something else to be mentioned. Like we're going down the rabbit hole. We're explaining front end, we're explaining back end, we're explaining all these parts and pieces. But I would say, like, as a back-end developer in your day-to-day job, you're maybe touching 1 or 2 of all of these things that we've mentioned, and we're going to mention more. So I would say try not to be overwhelmed, because I mean, in a way, we're giving the background of like not an entire, but like we're covering things that a college degree would teach over like 4 years. I mean, you could probably teach it in less. I don't know. Forget I mentioned that. This is probably funny. IP over avian carriers. In computer networking, IP over avian carriers is a proposal to carry internet protocol traffic by birds, such as homing pigeons. This is actually hilarious, and it actually is a good metaphor for those of you that are like new to absolutely all of this, because you might be wondering, like, how can you transfer data over a wire? I mean, you can. You do it with bits. Then we get down to zeros and ones. I don't think we're going that deep into the rabbit hole. But if you imagine, like, let's say this is how DuckDuckGo worked. Whenever I typed in the word banana here, I took one of my carrier pigeons, I put banana onto a little piece of paper, strapped it to its leg, and I sent them off to the DuckDuckGo servers. That pigeon would then return with a list of all of the suggestions, right? And so like it gets sent off. DuckDuckGo responds, so the pigeon comes back with all of these responses, and then let's say, oh yeah, I do actually want to search for banana bread. So now I attach banana bread to that bird, and I say I actually want search results. And so, poor pigeon, that's a busy pigeon. And so I attach that, the pigeon goes off, and it's like, all right, instead of coming back with suggestions, I'm now going to come back with recipes for banana bread. And that's how the internet works. Sort of. Yeah, check this too. Rubber duck debugging. We can talk about that for a second. Yeah. So I mean, here's the thing. Like we're answering the question, what is backend development? We've talked about all these parts and pieces. We haven't exactly talked about like programming and code yet. Like the code we write goes into these APIs, and the code we write interacts with databases. And the code we write on the front end makes the user interface happen. But often, when you're writing code, things go wrong. We're human. We make mistakes, and typically, we do what's called debugging. I guess we could let's start going down a different rabbit hole. We'll come back up. We'll come back up to this rabbit hole though. Never underestimate the bandwidth of a station wagon full of tapes hurling down the highway. It's actually really interesting because a lot of companies that do data backup allow you to send them a hard drive, because it's actually faster to put all of your data onto like a 5 terabyte hard drive and then just overnight it. Sometimes it's faster, I don't know, and then overnight it to where you want them to store that data. And then if you calculate the bandwidth, that's potentially faster than if you were to just try to upload everything over the internet and over wires. Yeah. So the internet still works with pigeons. Yeah. No, but maybe. Yeah, and so this is where we get into the one of the security aspects. You could have a man in the middle hijacking those pigeons, right? So I guess we can go here, but because it's kind of interesting to think about, right? Because when I type in banana bread or just banana, I expect to get back these suggestions, and these make sense. But if we think about that example for a second, where like I put the word banana onto a piece of paper, I attach it to a pigeon, and it goes off to get the results. If on the way back that pigeon is intercepted and modified, it could do malicious things. Like this could come back with different results that weren't the actual intended results. And that's an example of like a security exploit where you have this man in the middle or woman in the middle, this person in the middle, messing with your little messages on those pigeons. So ultimately, the data that I get back was not the official, like, original data. And then the pigeon ate all the banana bread. Programming is about logic and translating that into whatever programming language you choose. Yeah, I would agree with that. And the interesting thing about it is, like, we're not even talking about programming right now. We're basically talking about how all these things interact and what's involved with them. You can dive infinitely deeper into how do we actually write code that builds these APIs, or how do we actually write code that interacts with databases, or how do we actually write code that builds a front end, that kind of thing. Yeah. Am I bumping my cam? Yeah. So every time I move my desk, my camera moves because it's actually and I have a light right here that you can see in the corner right there. I'm not going to worry about it. I guess I could bring this down a little bit. Yeah, perfect. Wait, now what's over here? Oh, this is... What is that? Oh, it's my soda. Welcome, B-Fox. Thanks for being here. It's also cheaper to ship the drive than to pay for all that bandwidth at large enough scale. Yeah. I remember reading like a Reddit post a while back about like the bandwidth of a Boeing 747 just completely filled with hard drives. Is insane. Like could never be matched on like a physical wire network. Your VPN went down. You can't do anything. Well, that's unfortunate, Fireball. Thanks for tuning in. Hopefully that gets fixed. Not yeah, you're right. Not even on the way back, also on the way there. Yeah, so what if, so if we're talking about this, a person in the middle attack, what if I type in the word banana and then attach it to a pigeon, but on the way to DuckDuckGo, that pigeon gets intercepted and they replace that word with something else? That's an example of a person in the middle attack as well, because the information I'm trying to send is being modified in some way. How do you build a reliable message protocol on top of an unreliable pigeons? Yeah. This actually gets into TCP versus UDP. Because the TCP protocol has acknowledgement packets. So basically you send something and then you wait for the acknowledgement. You wait for the thing you're sending something to respond to say, yes, I got that data. And that's how you can guarantee that data is making it back and forth on this network over these wires. Where UDP is like set it and forget it. You just send it. You send as much as you want or as much as you can, and you don't care whether or not it made it there. You're just sending everything that you can. But yeah. IP over avian carrier has been successfully implemented, but for only 9 packets of data with a packet loss ratio of 55% due to operator error. Nice. A human in the middle. There we go. Is there a difference between programming and coding? You can get into the semantics of it. Yeah, a lot of people will say that coding doesn't require any thought. It's just the act of putting code into the computer to make something happen, whereas programming potentially involves more architecture and thought and design. I say they mean exactly the same thing. So whenever I say that I'm writing code or I'm coding, to some people, they would consider it programming rather than coding, but that's up to them. Like you could get into that, but for all intents and purposes, they mean exactly the same thing. Yeah. Oh, you use the Shakespeare programming language. That's a fun little rabbit hole. But we haven't finished this rabbit hole yet. I still don't think we've defined what. I mean, in a way, at a high level, we've defined what backend development is. But I still want to actually get into HTTP requests and responses because HTTP is a higher level protocol built on top of TCP, and this involves requests and responses. And this is how the majority of the web works. And actually, it is interesting to note that, so we talked about the internet, which is this series of connected computers, but the World Wide Web is actually the computers that are communicating with HTTP, Hypertext Transfer Protocol. There are computers connected to the internet that aren't web servers and that aren't working with HTTP. They're file servers, or they're just servers that you can remote into and stuff like that. So that's interesting to note. Okay. What was I going to do, though? I was going to look up... Oh, yeah, we won't talk about Shakespeare programming. That's completely unrelated. Oh, yeah, well, yeah, Game of Thrones absolutely had, like, messenger pigeons, yeah. Yeah. Never underestimate the bandwidth of a fully loaded truck, right? Yeah, so high latency of a Boeing 747, but high latency, but also extremely high data transfer rates. Yeah, pigeons for latency, 747 for the bandwidth. Yeah, it's really interesting. I mean, there have been a few people trying to change the subject, but it's like we're specifically saying we're going to keep answering questions, but yeah, I don't know. I program with HTML. Nice. Please go deep into HTTP. Yeah, we'll talk a little bit about it for sure. HTTP protocol. Yeah, so because it stands for Hypertext Transfer Protocol, if you see HTTP protocol, it's protocol, or FTP protocol. You could say FT protocol or HTT protocol. Nobody says that, though. Would you say that much of the internet today is running via RTC? I have no idea. What is RTC? Remote transfer? What? Let's look it up on Wikipedia. Technology. Real-time communication. Is that what you mean? Oh, like WebRTC. Yeah, what's the difference between HTTP and HTTPS? We'll talk about that. What's up, the Tim? I seem taller today. I'm standing. I mean, usually I'm sitting. I don't know. We haven't talked about clean code. No, because we haven't really talked about code at all. We've kind of just... The question we started with is, what is backend development? And to define that, we had to differentiate with front-end development, and we're kind of all over the place now. But yeah, real-time communication is something we can talk about, because that's happening right now. If you're watching this, it's happening right now. Like, in the Twitch chat, just type 1. I see myself that I have typed 1, but in a few seconds, people will likely respond with 1, like that. And that's real-time communication, for the most part. There's some delay, obviously. There's some latency. But the fact that I can see that people have typed this in fairly real time, that's real-time communication. It's happening, yeah. And that's how a lot of the web works these days, but not everything is technically real time. But I mean, a lot of it is, like, if you think about Twitter, I mean, I don't use Twitter that much, but I know, like, if I post a tweet, real star time, yeah, there's some latency, but if I post a tweet, other people that are following me will potentially get a notification that I've posted a tweet, or it'll potentially pop up on their screen automatically, and all of that's happening over real-time communication. Basically, I post the tweet, that goes to Twitter's backend servers. They have a backend, right? Those backend servers like put my tweet into a database, and then those backend servers look in their database to see look up to see what are all the users that are following the person that just posted this tweet and that have notifications turned on or that might care about this tweet. And then they have that list of users, and then for every user, they then potentially send them a push notification if it's a mobile device, or if they're in the web browser, they might get a WebSocket message that says, hey, this person just posted a tweet, and then it automatically pops up. I don't know. We'll stop talking about that because we do want to talk about HTTP now. We do want to talk about HTTP. Yeah. Yeah, but so many more things are real time. You're absolutely right, SQL Gordster. Demozo says, we've gotten so used to things like this that we often overlook just how amazing it is, and we can watch CJ explain things from across the world. Yeah, it's pretty crazy. Twitch is an amazing thing. I mean, the web, the internet is an amazing thing. Yeah, okay. Useless fact, www is the longer way to say the World Wide Web. www. Yeah, wait. 3 times. It's 9 syllables. World Wide Web is only 3 syllables, which is why I say dub, because that's 3 syllables as well. www. My phone and Twitter don't agree on real time. You're normally 20 to 30 minutes into the stream by the time my phone gets the tweet. Yeah. This, my friends, is an example of latency. And Limotes, thanks for that 9-month resub. That's awesome. But yeah, latency is when things don't happen immediately. That's a lot of people experience this, actually. Yeah. What's far more impressive, in my opinion, is if you think about what goes into those sub-second DuckDuckGo search suggestions. Yeah, I mean, yeah. I mean, this technically isn't real-time communication, but we're communicating with the backend in real time. Like the fact that I can type anything in, like yerba mate, and almost instantly I get a list of suggestions that are probably based on searches that other people have made. And it's sub-second, like it's just happening. That's crazy. Like it goes through the tubes of the internet, and then it goes to a backend server, and then that backend server has to query a database, and then that database has to respond, we'll give back results of that query, and then the data needs to be encoded to be sent across the network, and then it gets sent back across the network, and then somehow it makes it back to my computer. You show me this list? Yeah, it's pretty amazing. It's pretty great. Hello from 1900. Can you guys explain why do you have photos and symbols besides your names on the screenshot? Oh, yeah. Welcome to the stream, Vens. Badges. You can put a brand. I mean, there's also like programming languages and stuff like that. If you go there, so like this person has Vue, or one line of me has Vue. Doc has the Linux being one. That's all there, and then you can also set your country with that. Dub 3 is faster than dub. How do you say dub? Double? Is that how you say W in German? I used to speak German. German.
V.
Oh, V. V.
V.
Then how do you say V?
Foul.
Oh, okay. Great. Oui. Oh, VVV. VVV. Yeah. Latency is when you say hello to CJ and you get a response back 47 minutes into the stream. You're not wrong, American 2050. Querying a distributed database with trillions and trillions of pages and words. Yeah. It's pretty crazy. Pretty crazy. I guess if you see it that way, every technology uses real-time communication. It's probably the response time which makes it real-time. Yeah, but technically, like, this isn't really the definition of real-time because we're not really communicating with anyone else. We're just getting data from a server. Whereas if I could see all the searches that other users on the website were making at the same time, for some reason, that's more of an example of real-time, I would say. Real-time communication. Yeah. Oui. What's up, Wucha? Thanks for being here. Is WebSockets the only way for real-time communication? No, we could do long polling. and then there are potentially some other things. But this is another rabbit hole that we could go down. Yeah. Yeah, that's kind of why I do all the things, Acid Spark, is so I premiere a video because most people, for whatever reason, if they get YouTube notifications faster than anything else, will probably check Twitch to see if I'm actually live. And then I tweet, and some people get that instantly. And then I send a Discord message, and Discord is pretty good. Like usually, I think the longest I've ever, the most latency I've ever seen from a Discord like at everyone mention is like maybe 3 minutes. But even then, it's still pretty good. What's up, TD Racing? Yeah, see, Chris saw me on YouTube, came to Twitch. Yeah. Okay. Where were we? Kim, welcome. We're actually talking about what is backend development today, Kim. And anyone else just joining us, let's do a quick recap. We already recapped a little bit, but we're trying to answer this question and we're going down the rabbit hole. So first of all, we define development. Basically, we're writing code of some kind. To define backend, we have to differentiate between front end. So we defined like what the front end is, and then we started talking about some aspects of the back end. But all of this has led us to the idea that, hey, these two things actually need to communicate somehow. And that brought us to the internet. So we talked about it's a network. It's literally a series of connected computers. We show that, this is a physical example. We have a wire plugged into a computer. That wire is plugged into a switch or a router of some kind. And then some other computer is plugged into that switch or that router of some kind, and then they all communicate like this. But then this is connected to other computers, and that's the internet. We talked about, we didn't talk about it in depth, but there is the Osi model. This is a thing you can look into more, and when you're getting a computer science degree, you'll learn about this in your networking class. And then we talked about, okay, so if the back end and the front end need to communicate, they need some sort of protocol to be able to communicate. And we talked about there are different kinds of protocols. There are like lower level protocols, and these things are very low level, and things are built on top of them. And what we're about to get into is HTTP. So HTTP is a protocol. It's the Hypertext Transfer Protocol. And it's how most of the web works. I'll define HTTPS really quick. Hypertext Transfer Protocol. Can anyone tell me what the S stands for in HTTPS? I know it. I'm just asking you. Yeah, you're right. I did make an. Yeah, you're right. I did make an entire video. Secure. Yeah, it's secure. It's secure. And a little bit earlier, we talked about security as well, because the question came up is like, why are we separating the front end and the back end? Why can't it all just be in one place? And we talked about security. When you go to a website where you log in, you only want to see your data. You don't want to see other people's data. And when you change something, you don't want other people to be able to change your data. So that's one aspect of security. The other aspect of security is this idea of the person in the middle of attack that we talked about earlier. Because we talked about, and actually it was a really good example of, all the communication on the web for the most part is happening over wires, different kinds of wires. But someone posted this example, which is actually really nice if you're new to this stuff, because it's a good way to think about it. This IP over avian carriers. So this is a protocol where you could transfer data. It is an April Fool's joke, obviously, but it's the idea that you're using carrier pigeons to transfer data for computers. And we talked about, what if someone intercepts that pigeon, either on its way to deliver the message or on its way to bring back the response? If someone intercepts, that's an example of a person in the middle attack. And you could think about it this. If everything you do is happening over this hypertext transfer protocol with requests and responses, if somehow there were a person in the middle that could see all of that traffic, they could eavesdrop on everything that you're doing, right? They basically get to see every single message that you send. So, for example, if DuckDuckGo was not HTTPS, when I type in the word banana here, or potentially some other embarrassing thing, if this was not traveling over HTTPS, it would be completely in plain text. So if there was a person in the middle, that intercepted my traffic, they could see that I searched DuckDuckGo for banana. But if we use Hypertext Transfer Protocol secure, whenever I type in the word banana here, what actually gets sent across the wire is encrypted. It's encoded. It's basically reformatted so that no one else can see what I actually just typed into this search box, except for when it makes it to the server that I'm making the request to. And so that's the difference between these two. Is HTTP is actually very prone to man-in-the-middle attacks, or at least eavesdropping, where anybody that's on the network can see your traffic and see everything that you're doing, which is why pretty much everything these days is Hypertext Transfer Protocol secure. So it's still working over HTTP, but there's this extra layer of security so that if there were anybody that was attempting to eavesdrop on the network, they couldn't see what you're actually doing. They just see an encoded, encrypted version of that. Yeah. Should we differentiate between HTTP versions? We could, but the thing is, like, I don't. That's potentially another rabbit hole. And I say I don't when I'm explaining these things, because right now it doesn't really matter. But yeah, there is HTTP. I think like 1.4 that is like the latest version of one. We could look up HTTP really quick. HTTP 2. This is not my IP address. HTTP 2 is still HTTP. Oh no, 1.1. 1.1 is what it usually says. But HTTP 2 potentially allows multiple things to be transferred across, like from a single request, instead of having to make multiple requests. But we haven't really even gotten to like what is a request yet. So maybe we'll talk about versions. But first, let's actually talk about requests and responses. And we differentiate between the two. So HTTPS is HTTP over, it's secure. It's encrypted whenever things are happening. For all intents and purposes, like when we're talking about requests and responses, we can still just refer to them as HTTP. And then when they actually happen, they're encrypted, and we don't even have to care about that. Like basically, from a front-end developer's perspective, as long as the API they're making the request to is HTTPS, it all just happens transparently. Now, obviously, there was a lot of work that went into making that happen. Like browsers need to understand certificates and need to be able to load websites like this, but we can see that this request is going to HTTPS duckduckgo.com AC and Q equals banana B. So because this request is going to a server that is running HTTPS, this request was actually encrypted across the network. So if anybody was watching my network traffic, they would just see encrypted junk. They wouldn't be able to actually see that I searched for banana bee. Yeah. How does the server know the right method to decode the encoded message over HTTPS? It has to do with certificates. And so a specific certificate is used to encrypt the data, and then used to decrypt the data on the other side. And not the certificate, the public and private key. I'll be honest, I don't know really that much about it to be able to explain it that well, but that's about all I know about it, and I'm still able to do my job and at least explain that little piece of it. But you can absolutely learn a whole lot more about encryption methods and certificates and how all of that works, but that's all I know. And look at me. I'm on Twitch. The cool thing about protocol is DuckDuckGo via HTTPS would just work using IP over area, AVN carrier, and be just secure using pigeons. Yeah. So so our end goal of all of these protocols is to get two computers to communicate. And Soldier, thanks for that resub. But that's what we talked about a little bit earlier. We have these two disparate computers. They could be on two opposite sides of the room. They could be on two opposite sides of the world, But these two computers need to communicate somehow, and they do that by connecting them via wires and transferring data over that wire. But at the end of the day, if all we want to do is allow two computers to communicate, as long as there is some defined protocol for those computers to communicate, they could still do it. So basically what we're saying is we could get it to work with pigeons if we really wanted to. Does the SSL certification mean it's secure, or do we have to code it? So there are SSL certificates, and then you can run your website through some sort of like analysis tool to tell you how secure it is in terms of like, are you using, does your server support like the latest version of TLS and stuff like that? So you're not getting, it's not like a third party is certifying your website as secure. If that's what you're asking, that's not a thing. Though you can do that, but no, like in the general aspect of using the web, that's not really a thing. It's more about you get a certificate issued by a specific certificate body that web browsers and other apps and devices have agreed upon that these are trustworthy third parties, and it will only allow the website to work if the certificate was issued by one of these trusted third parties, and that certificate matches the domain name that you're getting the data from. So yeah, that's a thing. We're 4 minutes behind on chat though. We got to keep going. Hot take: in 2021, we can skip discussing HTTP 1.1. Well, I guess so, but like when I do talk about the HTTP request response cycle, that kind of has HTTP 1.1 in mind because we're thinking of it as separate requests and responses. Whereas with HTTP 2, the connection stays open and data is transferred between that. So, yeah. There's still potential for DNS cache wars. Yeah, so I'll say this. There are attacks and vulnerabilities all along the way. So like when we're transferring data, it's possible that there's a person in the middle that can intercept that transferred data and modify it or do something bad with it. If we have a web server that has an SSL certificate and it's secure, it's possible that there's some other attack happening where even though it appears that this is HTTPS, it's actually a bogus certificate, and that person in the middle actually issued that certificate, meaning that person in the middle can actually decrypt your encrypted traffic. So yeah, the short story is that absolutely everywhere in coding and programming, there are vulnerabilities. There are things that if you don't do them right, they could potentially be exploited by bad guys. And there's a lot of bad guys on the internet, and bad girls, bad people in general. Yeah. What's up, the real BRX? I am using Firefox Developer Edition. I know it looks a little bit different. Like I have these pinned tabs and there's like a spacer here, but I'm using the default dark theme. But this is, this is actually interesting because we're talking, the question that we're answering is, what is backend development? And I specifically have downloaded the Firefox Developer Edition. You have to take a 40-hour course and you have to score at least an 80% to be able to download this and be qualified as a developer. No, I'm just kidding. Anybody can download this. The idea with the Developer Edition is it's like early release. So it has some newer features that aren't in Firefox stable yet. So there are developer tools built in here that like help me with debugging, like writing code. And these are always like the latest version as well. But I don't know if that joke actually landed. For a second I was buying. No. Anybody can download it. Yeah. So you don't actually have to be a developer to use the Firefox Developer Edition. And you could absolutely just use Firefox Developer Edition with people actually bought it. That's funny. Okay. You could have it installed without using any of the development features and still get like the latest features. I guess, does Firefox have Canary? Canary? Beta. So yeah, so this is potentially another option, is to download the Firefox beta. Oh, and then there's the nightly build. There's a lot of different versions, but I use the developer edition and it works fine. Okay. Let's keep answering questions. We still have to talk about requests and responses, but Gene, thank you very much for those gifted subs. Much appreciated. One has to apply to get a certificate signed by a certificate authority in order to use HTTPS and have to appear as a trusted website and receive the coveted green lock symbol. Yes, though Firefox is no longer showing it as green, it's just a regular lock. Basically, because pretty much every website these days has to be using HTTPS. And thank you, Gene. I really appreciate that. Yeah, I appreciate it. Thank you. Thank you. Yeah, so that's the interesting thing about HTTPS is there are these trusted bodies. And if one of those trusted bodies has issued a certificate, your browser accepts it and shows this little padlock here. But what if one of those trusted third parties was compromised? Then the attackers that compromise them could generate fake certificates. It's a thing. It's a thing that happens for sure. But while we're on this topic, I'll go ahead and mention Let's Encrypt. Because this is a recent development in the past few years. They are a certificate authority. So they've become a certificate authority, but they issue certificates for free. For a long time, on the web, when you were building a website and you wanted it to be on HTTPS, you typically had to pay like $100 a year to one of these certificate authorities for them to issue you a certificate. But then Let's Encrypt came along, powered by I believe the EFF, the Electronic Frontier Foundation, and they're just like, hey, we'll issue certificates for free. And then that really helped speed up and get more people on HTTPS websites because they didn't have to pay the $100 a month to get a certificate issued. So that's a thing. There's a good explanation. What's this one about? You get a briefcase, put your files in it, then you lock it with a lock from the people you're sending it to. Only they have the key for that lock, so you send it and then they unlock it. And if they want to send stuff back, they use a lock only you have the key to. No, this is good. Yeah, so this is a very high-level description of what's happening with encryption. So I talked about when this information that I've typed in here, a banana? What the heck is a banana bag? Well, I guess there's probably bags that prevent your bananas from going brown. Regardless, when I type this in, this request I mentioned is going to an HTTPS server. And so because of that, the traffic is encrypted. And what we're saying here is like, this is kind of how encryption works. Like you take what you're sending. So in this case, the data I'm sending is banana ba. I put that into a briefcase, I lock it, and DuckDuckGo are the only people that have the key to unlock that briefcase. So I attach it to my pigeon, a very beefy pigeon that can hold a briefcase, makes it to DuckDuckGo. They have the key, they unlock it, they see that I typed in the word banana ba. And then they get this list of results, banana bag, banana meatball, banana bars. They put it into a briefcase that only I have the key for. They attach it back to the pigeon. At this point, he's really ripped because he's been doing a lot of work. He makes it back to me, and then I can unlock it. It's kind of like encryption. Basically, in between here and there, let's assume there are no good lock pickers, and so it's secure enough, and it makes it from here to there without other people seeing the data that I'm sending back and forth. Yeah. When we use a browser, can that browser read after data when we make requests and get its response? What do you mean? I don't know what you're asking here. Yeah, I don't know. Yeah, that's a good point. Thank you, Andrew. Picking the lock is very difficult and would take years, except for probably the NSA or government organizations. I would have to believe that they have strong enough computers that they could like really, because really the only way to break into that briefcase would be to pick the lock. In the programming world, one way of picking lock is brute force, where basically you try you have every single possible key printed that could open that briefcase, and you try one at a time. You try every single key one at a time. Eventually, if you have created every possible key for opening that briefcase, eventually you're going to find the key that works. And that's an example of brute force. And that's how a lot of things that potentially could decrypt the traffic would work, is they would have to brute force to find the key to be able to decrypt it. So the NSA can see everything we do, probably. I don't know. The NSA is like the lock-picking lawyer. Yeah, he can break into any lock, for sure. Yeah. So I haven't seen his channel specifically, but I saw the other guy that tried to make like the unpickable lock and then I think he sent it to the lockpicking lawyer, right? I don't know. Yeah, then we could talk about, in terms of brute forcing, we could talk about rainbow tables, which actually makes it a whole lot easier to brute force something because you're working with pre-computed hashes. I don't know. We still need to talk about HTTP. Let's see. Does a headless CMS count as a backend dev? Yeah, I would say so. Yeah, I mean, especially, I mean, what comes to mind for me is something like Strappy. Because with Strappy, you actually, like, when you're running it yourself, you actually install it as a dependency in your code base. And then if you look at their documentation, like, you're actually writing a lot of backend code yourself. You're writing middlewares, you're writing, headless. If you are working in the headless CMS itself, you could call yourself a backend developer. Now, if you're just consuming that API on the front end, maybe you're not necessarily a backend developer, but yeah. Yeah. Yeah, you can launch Firefox with different flags. I'm not... Maybe you can do that experimental to get features that aren't automatically enabled, but yeah. Oh yeah, I totally forgot though. Somebody mentioned this earlier, and we left it off. But they mentioned the idea of rubber duck debugging, and so we were talking about no matter where you are, whether you're writing front end code or back end code, or even if you're writing protocol or network code, that code might have errors. You might have done something wrong, and to fix it, in the programming world, we call that debugging. And the original like debugging actually came from one of the first computers, had a literal bug in it because the computers were like the size of rooms and such. Let's look that up. I think it was Grace Hopper. Grace Hopper found the first bug. Yeah, origin of the term. The term bug and debugging are popularly attributed to Admiral Grace Hopper in the 1940s while she was working on the Mark II computer at Harvard University. Can we see a picture of the Mark II? Yeah. The Colossus Mark II computer. I just want to point out that, so when was this? Mark II was in the 1940s? Okay, so all of this stuff you see on the wall here, like that's the whole computer, right? That all of that, there's probably more that we can't see. This is also a computer, and this actually probably has more processing power than that entire room of computer, which is insane. Insane to think about. This is what, I mean, at this point, 80 years ago? Almost 80 years ago? But, yeah, what a time to be alive. But, okay, so the computer's the size of a room. Things are really big, right? So she was working on it, and in the log entry of what was happening, she actually pasted in the moth that was found in the computer that was stopping it from working. So she literally debugged the computer because there was a bug inside of it. But let's look at this. So the term bug in the sense of technical error actually dates back to 1978 and Thomas Edison. There's a whole article on software bugs. Similarly, the term debugging seems to have been used as a term in aeronautics before entering the world of computers. Cool. So I associate it with this, but apparently it goes back even further than that. Look at the history. In Middle English, the word bugge or bug is the basis for the terms bugbear and boogaboo as a term for monster. Okay. Baffle Ball was the first mechanical pinball game. Let's take a quick stretch. That was advertised as being free of bugs in 1931. Problems with military gear in World War II were referred to as bugs or glitches. Okay, I think you get the idea. Basically, a bug is something wrong, something not behaving as it should. And debugging is the act of figuring out why is it not behaving as it should. Rubber duck debugging is a specific type of debugging where basically you explain the problem you're having to a rubber duck, a literal rubber duck. And it is said, and I can attest to this because it works, by explaining your problem to the rubber duck, you actually can arrive at a solution to that problem, possibly, because if you say it out loud, you're thinking through it, and your brain is exploring more neural pathways, and possibly you might be able to actually figure it out. So this concept of rubber duck debugging is just explaining your problem out loud instead of just keeping it in your head. It also works with other people. Like, you don't have to actually explain it to a rubber duck. You can just explain it to another person, and that person doesn't actually even need to talk, but just the act of explaining the problem you're having will potentially help you figure it out. Okay, let's close all this. I'm way behind on chat, by the way. We're like 11 minutes behind. Yeah. But yeah, well, it might have been YouTube chat at the time, but people did suggest that I use Firefox, and I have switched. I mean, I switched for my own reasons too, but you only get the green for high level certificates? Really? That may not be the case in Firefox. Look, I'm on Google and I don't even get a green. I don't even get a green padlock, so I'll see this message in 10 minutes. We're going to scroll pretty fast. Yeah, I think one of the websites that is still HTTP is example.com. Yeah, and you can see there's a little cross mark through here that says, your connection is not secure. But obviously this is an example website, but basically if there was anybody else on even my local network, or anybody else between me and the server that hosts this website, they can see all of the information in the request that I'm sending here because it's not encrypted. So that is a thing. Yeah, what Let's Encrypt did was a beautiful thing. It really was. I don't have a banana. No, I don't have a banana bag. Azure, are you saying the certificates on Azure are $60 a year? Yeah, no, exactly. And this is what I'm talking about. Like, I would say if you are like a cybersecurity expert, which I don't claim to be, like if that's your job, that's what you do for a living, or if you're like a DevOps person and you actually do a lot of managing of certificates, I think it would make sense to know a lot more about like what's happening there. But for the work that I do, I let you know about my shallow knowledge about it, but it's enough. It's enough to get it to work. Instead of a pigeon, it's a duck. No, it's different. You're explaining the problem to them. All right, we're gonna scroll fast. We're gonna miss some things, but that's okay. Okay. Obviously, we didn't explain everything, but we did talk about a lot of different things. Look at all this. We talked about all this. A lot of this stuff. At least touched on this stuff. And this stuff. We talked about a lot. I think I might potentially like pick one more thing and then just talk about it for like 20 minutes or so. Am I ever going to teach cybersecurity stuff? I might do just like web security because I know a lot about that. Do all computers have their own SSL by default? I'll say this. Your web browser has a list of trusted certificate authorities. So Firefox, and also operating systems do as well. When you install Windows or when you install OS X, it comes with a list of trusted third parties. Let's Encrypt is one of them. Let's Encrypt is literally on this list of trusted third parties. And so when you go to a website, it first, like it gets their certificate on that website, and it verifies that the signer of the certificate, like we can view the certificate. So we have the website, and then what do we have? Oh yeah, we have who is the issuer. And so your web browser or your computer will look at this issuer field and make sure that this right here is in the list of trusted authorities. And if it is, it trusts their certificate. That's it. If your list of certificate authorities is compromised, then it's possible that it'll validate things that actually shouldn't be validated. Yeah, that's interesting to see though that like Let's Encrypt is actually encrypted by Let's Encrypt. Well, it has a certificate issued by Let's Encrypt. So like they verified themselves. That can't be legit, right? Like why do we have a system that works that way? I don't know. Yeah, it's interesting because like in the world of certificates, you can have a self-signed certificate, which means like you sign that certificate on your local computer. It wasn't issued by a certificate authority, but in this case, it's a self-signed certificate that is actually valid because they are a certificate authority themselves. Yeah, I think we'll talk about DevOps next because somebody did ask about that earlier. Yeah, but. Yeah. If they use other party certificates, wouldn't that be sus? I don't know if it'd be suspicious. I'm just commenting on the fact that like having a trusted third party is always a weird concept. Like you have to trust somebody somewhere. If you can't trust someone, all communication breaks down. So there has to be some trust somewhere. But because of that, the system has potential for abuse, where you have issuers that maybe don't have secure practices and then they are compromised and then people are issuing certificates with their name on it, even though they're not legitimate certificates. I don't know. No, and I'm not picking on Let's Encrypt. I'm picking on the general idea of certificate authorities in general. Let's Encrypt is great. Yeah, but I'm picking on the idea of all of the other ones that are out there, like Komodo and all these big corporations. Yeah, I didn't trust DigiCert, GoDaddy. Wait, I didn't know GoDaddy was literally their own certificate authority. Interesting. Global Sign, Intrust, Sacom, Trustwave. So all of these are examples of certificate authorities. All of these issue certificates. And we just trust them. Okay. Yeah. All right. We're gonna skip all the. I missed a lot of messages. If you would like me to see your message, you can say it again. I think what we're gonna do is just pick another question. First, I want to thank Lakshman for asking what is backend development. Obviously, I didn't answer all of your questions, but I think it was fun. Going down the rabbit hole, and like I mentioned, like there are infinitely more rabbit holes we could go down to explain stuff here. So let's answer this one. It does have the most upvotes. I mean, that one has 3 upvotes. This one has 3 upvotes. Oh, it's good to hear, Lakshman. Yeah, good to hear. Let's just talk about this because it's somewhat related to backend development. So some of the things that we rabbit holed into, we won't have to rabbit hole again. DevOps. Let's talk about DevOps. We're going to call this what is backend development. We're going to make a new file called what is DevOps. All right, and we're only going to go down this rabbit hole for like 30 minutes. Someone at CERN decided to experiment with rendering SGML documents over TCP, and it was all downhill from there. Are you saying that's what DevOps is? What are you saying, Doc? Yeah, I'll answer this question from Demozo. So, we've been talking about DuckDuckGo today, but I use DuckDuckGo as my default search engine. So if I type banana here, it searches DuckDuckGo. So that's step one. DuckDuckGo is my default search engine. The second aspect is DuckDuckGo has these things called bang commands. If you type exclamation mark, you can see an example of all of them. But for example, exclamation mark W searches Wikipedia, or exclamation mark R searches Reddit. I use exclamation mark GH to search GitHub. There's also exclamation mark NPM, which searches NPM. What was the other one you asked about? Oh yeah, exclamation mark I just searches for images. DuckDuckGo images, !IMDb. Yeah, so they have a bunch of bang commands, and then I use those because DuckDuckGo is my default search engine. Yeah, not sponsored. DuckDuckGo is great, and I like them. That's it. Okay. I heard DevOps is a movement. Okay, first let's break it down. So DevOps is short for Developer Operations. Okay. Okay. Now, if you've been watching since the beginning, we actually did define development earlier. Like we talked about development being the writing of programs or software, and all, like you could say any one of these things. For the most part, they mean the same thing. Like we are writing code of some kind. And so this is writing code of some kind, operations. And we actually don't have to break this down anymore. Like this is the general definition of operations. It's all the things that need to happen for that, right? And let's think about what that involves, right? Because when we were talking about backend development, we did say that it's potentially hosted in the cloud, and that we're potentially building our own web APIs. And we have to care about security, and then there are databases involved. And that front end needs to be able to communicate with that backend. So if we think about the actual deployment, I guess is another word we can define. If we think about the actual deployment of all of this, there's a lot involved, right? So actually provisioning a server in the cloud for your code to run on would fall under developer operations. Provisioning a server with a database would be under DevOps. Potentially running or upgrading to the latest code on the servers that are running would be what someone in DevOps is potentially doing. So it's basically all of the work around all of the computers that are running the code that backend developers and front-end developers write. That's a general description. I hope if anybody out there is in DevOps, please correct me if I have. First of all, if I've offended you in any way. What are some other things involved here? But I'll say in general, the word deployment means to put code onto a server so that end users and clients can use it. So if I build my own web API, I need to put it on a server somewhere so that way it can be accessible over the internet. Or if I build a front-end website, I need to put it on a static host somewhere so that it can be visited over the internet. So, I mean, we talked about earlier the internet being a series of connected computers. I said you could host a server on your computer. You could, but if you did, it would potentially be really slow because all of the requests coming into it would slow down your computer. It's based on the network speed. Like if you don't have a good internet connection, it wouldn't be that great. So instead of hosting things on our own computers, we host them in server farms that have really fast internet and have a whole lot of processing power. Yeah, so I think so what I'm actually describing here is actually system administration. That's the like what we used to call it. And then DevOps itself actually has a further meaning of basically writing code that can help with all of these things like deployment. Whereas